Next up, we have Dr. Syed with his keynote speech.
Assalamu alaikum. I think good morning, class, good afternoon to all. First I would like to thank you the opportunity in this FEDA and as a keynote speaker. So Sir has mentioned Dr. Ponsar has mentioned about this global warming. Because of the global warming, only 5 important elements affected, you know very well. That is for air, water, and fire, and land, like soil, and etc. So everything is we have Sir has mentioned this. That is the information about this statistical reports Sir has mentioned, and similarly further what happened, how we can avoid everything again. But as a researcher and as a professor and as an academician and similarly for industrialists, we have to give further solution. So that is important one. We have to move for the in this our world. So for this part, we are very professor in this our focus in tsunami using the TIMPULSE-SIM models. So tsunami, only we know that tsunami affected all over the world in different places. Recently, particularly because of the global warming, a lot of the tsunami affected in the Japan and Indonesia and other that is Atlantic, and there's a lot of the places also affected. So in this course, what are the as a human being we have to save for our life for this our human and other things, because the global warming created by our that is our human being only. Similarly, for the solutions we have to give. That is our duty. So that's the reason only now all the research that is moving towards forward for a solution. So this type of tsunami we know already. We know that the type of tsunami we have. The tsunami can be categorized as a different part. That is first one earthquake tsunami, then volcanic tsunami, land-side generated tsunami, and mega tsunami. So 4 types of tsunami we have. So in this FEDA, each and every tsunami we have 3 phases available. First one generation, next one propagation, and third one runoff. So before the earthquake, because of this fault line and because of the under the earth we have some other chemical reaction and technological plate effect. Generation is happened. Then because of the generation, the water is very nearly more than 100 kilometers of height is come to this our land. That's why the propagation, and runoff is automatically because of this land, and based on this land structure, the runoff is height is more. That's the reason only we have affected in this all over the world. So this is the part we have the phase of tsunami. So tsunami protection by the agency in this all over the world, different type of the agency also moving in this to give for the awareness, similarly for the tsunami warning also we have. Tsunami warning center, particularly for the US geology survey also we have, and other part of national earthquake hazard reduction program also is conducted for each and every places to give the prediction for the tsunami. And what is the detection of tsunami? We have the following for the this type of this approach. The first one, that is for we have this that is one this is the top system. The top system is connected with the satellite. The satellite connected with this office. That is the control system of our tsunami warning center. So clearly seeing this the waves of the tsunami or the waves in the sea. Automatically the information is given to this top system. Top system used for this our satellite. Satellite gives the information to this particular control of this top system. So other than that is the top office will do the information and one is the. So this happen is all over the world. Similarly for this type of this point also mentioned is different places. The top system is all over in our particularly for our Australia and similarly for a lot of places more than 89 top station available all over the world. So what is the limitation of the tsunami early warning system? Because already we have the tsunami warning system, and what is the problem in the tsunami warning system actually? So what is the limitation what we have in this tsunami warning system actually? The tsunami warning system is created by this each and every government under the one that is for the agency. But this early warning system is very important because we have to save the life. Similarly, for you that some important information about the particular zone area peoples. But what happened in this, particularly in the tsunami warning system, is there is a false warning system is mentioned. So at that time, the people is affected many more. And some information also we received. That is, the tsunami will come. Tsunami we expected. Like that information we are receiving from the tsunami warning system. But it's not true. Sometimes it is 5 years. So this part we have to move further. Next one, there is a solution. So what is for example, it is our warning we have, in particularly for this in the particular area in Indonesia and other time also, lot of false alarming or lot of false warning system is mentioned there. So that's why the alternative solution, and we are moving for the next level, that is for the mathematical solution. So that's why the need for tsunami modeling. In the tsunami modeling, you have the primary purpose of the tsunami modeling. We have the purpose of the modeling is the risk assessment, and next one the early warning system, and hazard mapping and the land use planning, then engineering infrastructure design and education and awareness. So the objective of this research, objective of this tsunami warning is forecasting of the tsunami we have to find the earliest arrival time of tsunami. Next one, using a minimum number of input parameters, because at the time of the sudden happen in this particular time, we are not possible to get for all the parameters. If all the parameter only the early warning system is give the input, that's the reason only we have delayed information we received. So that's why we use a minimum number of input parameters, and we are possible to give for the solution, that is important one for the minimum input parameter. Next one, to reduce the computation time, that is after completing this using for our simulation modeling or using for our computer, our software, it is due for the solution within the 5 minutes. Thank you. So that's the reason only this we have to apply for the both the distance and the local tsunami. We have the two important parts we have. Apply for the both the distance and local tsunami, and apply for the long duration tsunami also. So the impulse-SIM model is an overview of we have created for the new model by this our team actually for the 3 part we have. What I mentioned is the generation phase and the propagation phase and the run phase. So the other part we have this created for the our simulation modeling using for our Python programming, and similarly for the algorithm also we have that is important. It is the impulse source based model, impulse and fault line based model, impulse estimated short distance based model, and impulse AB model, and impulse ADIR model, so this is a gap what we have identified, because before that I mentioned previously, the lot of the agency also they are doing for the different type of this simulation modeling, similarly for the early warning system also. So in this part we have the most, and tsunami 2 is a model already we have, and one wave and continuous wave contact also we have. So what is the gap we have identified not accurately captured because of this most. Similarly for this limits its that is applicability and not very efficient and requires specific input parameter and ideally for the condition and may not capture. And these are the things, the disadvantage also available in the previous what we have in this identification of existing model. So the advantage is the mean approach also we have, that is as I mentioned previously, the minimum parameter we have possible to identify the tsunami that is arrival time. And next one, important units, that is for this our similar to long duration or long scale tsunami, computation time is less than 5 minutes equal to you for the solution for this one. So that's the reason only we have advantage and the approach in this our next one, the methodology. We have the 6 important stages we have. First one, data collection. Next one, the parameter identification and mathematical equation modeling, and the program for equation and implementation and testing. So these are the steps we have crossed. So this is the step 1, data collection. We have data collected from this all over the world. What is important is of the government agency and other agency also we have collected using the barometric data, earthquake data, and other data also. Similarly for the parameter we have identified that is a technical point, because that's why I want to skip some other point, because magnitude and origin location and focal depth and deep angle, other things also we have. This is a technical part. So all the part we have considered for the civil problem based on this 5 input parameter only. But usually to develop for any modeling, minimum 15 parameters, more than 15 parameters required. Now we have identified, we have created for the algorithm, and so that is using for the Python and other algorithm, other program coding also. We have identified only 5 parameters enough to give for the solution of the tsunami arrival time as earliest arrival time also. So this is the mathematical formulation, this is the that is using for the representation of the 3-dimensional dominations we have. And next one, that is for the initial condition we have considered for the initial condition, that is the seabed is rigid and velocity seabed, the depth of the seabed, and the next one the fluid is equilibrium conditions. Like that we have considered for the some initial condition. And the phase 1, that is the generation, and we see that this is the framework for the there is generation, we have the seismic movement, and all the part we have considered. there is a plate boundary conditions and with rupture zone determinations, supercylindrical wave propagation, etc. So output we have from the phase 1, there is rupture zone coordination, rupture length, and time of rupture, and etc. These are the things we have received for the first one, that is for the phase 1 generation. Similarly, for the propagation phase also we have this identified, and we have that is completed for the propagation part also. And third one, there is a runoff phase. Again, the runoff phase we have a framework. These are the framework, using the framework, and we have identified the third stage, that is for the runoff phase also. So the generation and propagation and runoff, so all the part we have completed for this that is the algorithm and for the solution also. So next one, that is for the propagation for the modeling. We have already mentioned that using for the Python and other algorithm, more than 6 algorithms we have integrated, and apart from that we have identified the new 4 algorithms, and nearly 10 algorithms we are using to use the predictions of this tsunami applications. So this is the implementation, and the final part. This we have identified, and we have that is the mathematical formula and mathematical application also completed. But the problem is how we have to implement. The implement part is really important. That is, we have to give for the solution using the some simulation part. That's the reason we have implemented for the 5 different parts. First one, the location based we have identified, and similarly for the ocean based also we have identified. For example, North Atlantic, North Pacific, Indian Pacific, and next one for the continent based also. For example, Europe, North America, Asia, and South America and Asia also. Last one, the country based also we have identified. So different type of this implementation we have, and that is applied. And one more important I would like to mention here, we have integrated with this National Institute of Ocean Technology in India. There is a Institute of Science, and we have cooperated with this MOE, and this, we have completed for this part. So these are case studies for example, I will show for only 2 case studies. First one for the Indian Ocean Tsunami 2004, what happened, and how you have identified this parameter, what is solution you got. Okay, this is the 9.3, already we have the 9.3 magnitude got stuck in this December 26, 2004. Nearly now 2024, we are 2004 now. So at that time, we have 9.3 magnitude earthquake stuck in Indonesia, and a lot of the people, lot of the people is dead because of this the sudden tsunami. So here tsunami simulation result we got it using my algorithm, using this simulation model. The first one, that is for the generation of steady area and seabed displacement, and next one for the rapture line. You have the rapture line. Rapture line towards nearly 1,000 kilometers, 1,200 kilometers from the particular part to this Burma plate also crossed. So this is important part. Next one is the seawater deformation and generation zones. Then propagation phase also similarly for the, now I am going to identify Chennai to our that is for the Sumatra. The Sumatra to Chennai, what is the distance? The short distance also we have identified. And how to reach for the particular time, the earliest arrival time, what is the short distance? It is based on this algorithm, we are possible to give for a solution of the short distance also we have identified. And similarly for next one, it is the impulse ABP approach. Based on this impulse ABP approach, we have identified the totally 8 directions based on north, northwest, northeast, similarly for south, southwest, like that. So now we are in this from this that is west, northwest. That's why we have identified for the northwest approach. In the northwest approach, we have this each and every there is hours. You have the solution. That is for the first one, second simulation, and third simulation stage, and the fourth and the final. So what are the how the distance is moving and how this each and every stages that there is waves are moving. Everything you have mentioned here. And similarly for the impulse ADR approach, in the ADS approach also we have used for the 360 degree. In the previous one I have mentioned only for the some direction, that is maximum for 45 degree. But here 360 degree, what happened in this after this earthquake and how we reach for the ADS everything we mentioned. It is the impulse ADR approach. And next one, impulse ADR approach for the Japan tsunami 2011 also we have identified, and we got this output like this only. And this is the some validations and the value tsunami details. There is a train travels, the location and the model of data, historical data, time difference, what will the accuracy we need, that is based on this algorithm, nearly 10 algorithm and modeling, we got this 99% for the first location, and second location 92, 97, 90 and 95. Within the 5 minutes, we are possible to give for the solution for the airless arrival time for our people. This as compared to this our that is our yearly warning system is very useful for our people. That's the reason we have created. And similarly for the estimated tsunami wave carriers also we have based on this run-up, and similarly for the travel time, everything we have calculated. And finally another one basis, that is for the 2 phases comparison here. So listen here, 2004 Sumatra tsunami and 2011 Japan tsunami. In this, here the magnitude is 9.15, 9.1. But the fault length is different. So based on this fault length and based on the water depth, the total, that is the simulation models totally is it will reflect for the differently. That's the reason only we have to consider for that important point only. And propagation phase also we have this representation of propagation phase, how is occurring in 2004 and how is the 2011 and etc. And next one, run-up also similarly for the run-up, it is a presentation also we have, that is for the graph representation also we have the slope deviation that Chennai and Kanyakumari in the cross-section of Tamil Nadu and India. So what is the conclusion is the particular one, there is a minimum input parameter for forecasting of the tsunami behavior, and the tsunami can simulate using the primary available, what is the value we have. Based on this one, we are possible to predict the particular case. And apart from that, we have created for the designs of the prototype model also we have created to understand our student community, how this happened and how we have to movement of each and every stage like generation, propagation and etc. So these are the water displacement mechanism also we have, the pattern also we have tried for the pattern. So future scope, apart from that, we have using for the another one model also we are going to implement, that is for the 3-dimensional tsunami wave and solar automata. And thank you for your listening and thank you for watching. So any clarification you need?